Good morning, everyone. This is Sachin Biske from Electrical Engineering Department, SND College of Engineering and Research Center. Today, we are going to start the power generation or conventional power generation by using a PLC system. So, let us see some introductory part, that is, the energy demand is isolated or mode of the grid connected mode of application is steadily increasing, and thus it is very important to meet the continually increasing demand of the power. In this, basically it describes the modeling and simulation of a renewable energy based hybrid power system in the aspect of improving the power quality, energy management and control, because optimal utilization of primary energy sources will increase the level of supply reliability in order to meet the sustained load demand. During varying natural conditions, different renewable energy sources and converters are need to be integrated with each other. It focuses on the combination of a photovoltaic, that is PV cell system, wind turbine system, then fuel cell, that is FC, and battery system for power generation. And to improve the power quality, we are proposing the motor generator model instead of using static converters and an energy management and control unit using programmable logic controller. Since wind turbine output power varies with the wind speed, the PV cell output power varies with both the temperature and irradiance, and FC output power varies with input fuel, and so along with DC motor. Diesel engine is also coupled to ensure that the overall system performance under all conditions, especially when PV, wind, FC power is not enough to drive the DC motor. Excess energy, when available, is converted to hydrogen using an electrolyzer for later use in the fuel cell and for the economic use of fuel. The result shows that the proposed hybrid power system can effectively be a DC motor synchronization set and diesel engine set. See here, basically this energy demand in isolated mode or a grid connected mode of application is steadily increasing day by day, and thus it is very important to meet the continually increasing demand of the power. On the other hand, there is a global interest for global environmental concerns such as greenhouse effect and global warming and the reduction in the fossil fuel sources. The solution for these issues can be considered from the recent research and development of alternative energy source, which has excellent potential as a form of contribution to conversion power generation system. That is, to introduce the renewable energy such as photovoltaic, fuel cell, and wind energy. This is a clean and abundantly available in nature and offers many advantages over the conventional power generation system, such as low pollution, high efficiency, diversity of fuel, and reusability of exhaust and on-site installation. The system consists of a PV panels, wind power system, and fuel cell system. The electrolyzers are used to absorb the rapidly fluctuating output power at with load and generate hydrogen. The generated hydrogen is stored in the hydrogen tank and used as a fuel for fuel cell, which reduces the fuel cost. By combining the several different types of power sources, will form the system called hybrid power system, and this hybrid power system combines two or more energy conversion devices or two or more fuel for the same device, that when integrated, the overcome limitation inherent in either hybrid power system are designed for the generation and use of electrical power. They are available in two modes, namely islanding mode and grid connected mode. In general, the hybrid power system may be claim alternating current and diesel generator as a AC distribution system. To overcome this AC diesel generator is AC distribution system, a direct current distribution system load renewable power sources and energy storage power converters, rotary converters, and coupled diesel system, dump load, load management option, or a supervisory. In this system, the output of a renewable sources cannot feed the load directly because their voltage fluctuations are so large that they will damage the concerned load. So first it needs to be conditioned, and for that generally DC to DC and AC to DC converters are basically used. Thus, the varying voltage can be brought to required value and specific value limited by varying the duty ratio of the converter and then connected to the DC bus. So this is one of the proposed system that the DC bus voltage is now used to drive the DC motor coupled to the synchronous system. And electrical power should be productively externally at the same time when it is needed, and it may not be possible for renewable energy source like wind, PV, and FC to produce the sufficient energy to drive the DC motor coupled to the synchronous generator at all the time, since their operation depends on varying the natural condition. So diesel engine is also coupled to the synchronous generator to avoid the shortage of the power. In the proposed system, basically this DC motor, alternator and diesel engine are mechanically connected by using an electrical clutch. The DC bus is used for integrating and all the sources and storage of the energy like PV, wind and battery, etc. To have an optimum, efficient and reliable operation of a complex system consists of various power sources. A control is needed, hence microgrid controller which also acts as energy management unit is designed by using this PLC modeling and simulations are conducted by using a MATLAB simile and to verify the effectiveness of a proposed system. Basically, this fuel cell is a device that uses the hydrogen as the fuel to produce the electrons, protons, heat, and water. These fuel cells are electrochemical devices that convert the chemical energy of a reaction directly into the electrical energy, and it must respond quickly to changes in the load and have a low maintenance requirement as well as long cell life. The basic building block of a fuel cell consists of an electrolyte layer in contact with a porous anode and cathode on either side. In a schematic of a fuel cell, gaseous fuels are fed continuously to the anode and an oxidant, that is oxygen from air, which is fed continuously to the cathode compartment. The electrochemical reaction takes place at the electrode to produce an electric current. A fuel cell is individual small unit of around 1.2 volt. A group of units are connected in series and in parallel to get the required voltage and current rating. That group is called as fuel cell stack. Thank you.